My name is Yogi. I am, as it said, principal software engineer. I've been so many things over the years. I am not exactly new to Postgres. I started using Postgres in version 4.2. And what are you? Probably no. That was in 1994. And in 96, I started contributing to the Postgres open source project. That what? By fixing the remarking system. It was horribly broken. And then Postgres had views and all that working. So then we needed the reparse utility, the dump code, dump views. I have also created toast and the numeric data type for entries, the background writer, lazy vacuum, and PO colons. Yeah, but you're already different. Yeah, PO cut first too. You're correct, Robert. Absolutely. And then in 2003, a company hired me to specifically create a disaster recovery solution for them. Because 2003, we didn't have binary backup and restore or anything like that. And I created the Slony-I replication system for them, which by the way is still used, but it is still in use 20 years later. So now here I am 20 years later. What am I doing? Database apps. Yes, of course. Still database implementation. Something is how we probably puts that. Now, a recurring theme when it comes to replication are sequences. This topic is so old, like from the get-go, and slowly we have problems with the sequences. Now, I want to give a little bit of an overview of how sequences work, even though I expect that everybody knows what a sequence is. But there are a few details about sequences that are not immediately obvious, and some people stumble over them. So, first of all, normally one does not use a sequence directly. One creates a table and uses an ID column, or as we call it, serial column. Don't use serial columns. Use big serial. Okay? The difference is integer 4 versus integer 8. Why? Integer 4 is still the default when you say serial? I don't know. But that's the Postgres immunity for now. In a nutshell. It takes a long time to make other things the default once. Now, an important thing to know is that sequences never go back. So if you have a transaction, you do an insert, you consume a sequence ID, and then you abort your transaction before it gets loaded to something else, that sequence number is off. So these sequences, or the serial columns, cannot be used to create gapless increasing IDs. I've been originally a bank clerk. Very typical for database engineers. And oftentimes, people who come from an accounting background or so will put this requirement into your technical specifications. Yeah, for absolutely no good reason. Yeah? Don't accept such a requirement. You can't implement it. If somebody tells you this needs to be gap-free, and of course in chronological order, don't accept it. Because now you have a bottleneck in your database application. The moment that thing, whatever you have, you get a lock on and allocated a number, belongs to everybody else. Hallelujah, your 72 core server is now single threaded. Great job. So don't do that. And also with the chronological order, there is no such thing. They would have to increase monotonically in commit order, right? But that sequence is allocated long before you commit. You don't even know the commit order at that moment. So reject those requirements immediately. The first question I had asked back then when he created Slony, and I had asked that question again now that we do multi-master replication asynchronous. Do they need to replicate data? Well, in Slony we found, because that was a single origin, multiple replica system, yes, we do need to do something here for failover, for switching. Because otherwise, if the sequence is not incremented on the subscriber, yeah, after you fail over, you get depleted key values. Not good. However, what we did back then was, instead of really meticulously in small steps increment that sequence, well, screw it, just look at what is the current value there, or the last value actually, and bump it to that, okay? On a failover, there is a gap. But we already said they are not gap free anyway. Whether there is a large gap or a small gap, doesn't matter. What to me? Everybody wants to discuss this with me? No. I refuse that. But instead of doing that, I also came up with other ideas how to avoid replicating sequences. So first of all, we cannot have a central sequence generator. That's not gonna happen. If you go into AWS, for example, and you have a node in, let's say, Montreal, another node in Ireland, and our node in New Zealand, the two nodes in Ireland and New Zealand are about 270 millisecond round trip away. That's a quarter second. Forget it. Nothing safe. Yeah. But we can do individual number ranges. Okay? That works. Now, again, there are multiple ways to do this. When I say number range, most people think of, oh, I'm allocating the first million here and the next million there, and okay, yeah, these block allocations are horrible to maintain. Because then when your block runs out or is close to running out, you need to reallocate another block there, and you need to both keep something to eventually figure out, where did this sequence come from? This ID, where was it allocated? So I don't like it. However, there's another way. These are also number ranges, strictly speaking. So what I do here is I create a sequence, but then I start it on a different number on every node in the cluster and increment it by 100. Okay? Now, nice side effect is the last two pictures tell me the origin of that ID automatically. Because the first one will increment in a sense like 1, 101, 201, 301, and so on. Yeah. Likewise, the other one will always have 0, 2 in the end. Okay. What I don't get here is any kind of relation to the oral allocation. If one node allocates IDs at a rate of, let's say, 100 a day, another one does 10,000 a day, I have no idea what any puzzle ordering that could be. And there is something that people I have seen doing is, okay, I have this incrementing ID. Give me the last 100 rows that were inserted. You do this in Multimaster with differing frequencies of allocation completely go. That requires a completely different implementation. Yeah, doesn't. So then we thought that we should do something else. And there is actually a concept. This is not necessarily 100% my idea. Snowflakes. You will see very big similarities between other implementations. But what I wanted to create is a drop-in replacement for Postgres sequences. When you create a table today and have a big serial column in there, then it has automatically a default setting for the column value of next val, the sequence, this trust, right? And there is a function, core that gives you the last allocated ID in your session. So even on the concurrency, if you insert something into a main table, you generate this ID. That ID is available to you under the name core sequence name. And you can have multiple in your session at the same time. Somebody else inserting into the same table allocated IDs does not affect your code. Some applications require that. And to be a drop-in replacement, we needed to satisfy that requirement. Now, what the Snowflake looks like internally, it is a 41-bit timestamp, millisecond resolution, a 10-bit node ID that needs to be set by PostgreSQL.conf, and a 12-bit counter. So within 1 millisecond, we can allocate 4,096 IDs per node. Then when the millisecond rolls over, it gets reset to 0, the counter. Right? 41-bit timestamp is not what I prefer, but we didn't have more space in there. It's going to be good for about 7. By then, I hope we have better solutions than this. This is really workaround for replication to have the feel of a sequence and the functionality and a drop-in replacement for now. Sometime around 2100. First of all, I don't click on being more, but by then, Postgres community should have created something that is. Now, how do they look like? Well, we of course have the functions nextval and curval, and we have a Snowflake element, which returns a JSON B, very tall, that shows you the ID, the 10-bit ID, which allows for up to 1,024 nodes. Well, actually, 1,023 zeros got you out. The time set in milliseconds and the count. Yeah. There are also a few functions that are convenient. Convert sequence to Snowflake. So if you have an existing database schema that uses serial or big serial codes, you can use this function to make sure that the sequence is locked down in a way that using normal Postgres next belt function will allow don't mix them. That will look in the system catalog, are there any tables that use this and the default expression? If so, change that default expression to Snowflake expelled. Make sure that the column is actually iterate. And then go recursively looking for foreign keys that reference that bit and make them in A as well. This is a convenience function for converting or migrating to Snowflakes. As an example, I created a table with fixed area. I then call the convenience function, convert sequence to Snowflake. It tells me what it actually executes. The SQL is starting here, as no way says. And it returns how many SQL segments it actually had to execute to convert this. It's just an arbitrary information. Okay? I find these. And then, after inserting some data, I can see here actually the timestamps generated with the count and so on. Okay? Why is the ID 0? It just said 0 is not allowed. But to go back to the drawing board. Anyhow, the nice side effect of being in milliseconds incremented, if your server clocks are centralized, and centralizing server clocks these days is really cheap. My servers at home, because I have servers at home, they are synchronized to about 10 or between 10 and 100 microseconds. Not me. That's because I have a GPS clock at home, and a GP server. Choose up Raspberry Pi with the PoE that and GPS module.